All right, this is our second video for graphing sine and cosine functions. The first video we covered what the parent functions for sine and cosine look like, and now in this video we're going to be focusing on sine functions of the form y equals a sine of bx and y equals a cosine of bx, okay? And we're going to see how the curves change as we bring these values of a and b into play in the function, okay? Now notice we have some stipulations on the values of a and b here. A can't equal 0, and b has to be greater than 0 right now, okay? These values are going to affect both the amplitude and the period of your function, okay? So let's start by looking at amplitude, okay? I'm going to illustrate this. All right, so notice I have the equation y equals 4 times sine of x. So I would say the a value of this equation is 4, all right? And the first thing you're going to see sketch out here, this is the parent function, y equals just sine of x, okay? And next we'll see the amplitude of that curve is 1. Remember, amplitude is the distance from the midline, which is the x-axis, to a high point or a low point on the curve. So that's 1 unit right now. Now we'll see the curve transformed into y equals 4 times sine of x. And notice what that 4 does. It gives us a new amplitude of 4 units. All right, and think about what's happening here. This is nothing more than a vertical stretch taking place, okay? What if a were a negative value? All right, let's reset this. And I'm going to make a, how about just like -2? All right. So now, once again, you'll see the sine function graphed. It shows the amplitude is -1, but actually amplitude is a distance, right? So you're moving 1 unit in the negative direction from the midline to get to that low point, okay? But I would say the distance you've traveled is +1 unit. So amplitude here is +1. Y equals -2 sine of x. Now you're going to be traveling 2 units down from the midline to get to a low point. I'd say the amplitude here is +2, okay? So in general, we're going to say that the amplitude of our curve is going to equal the absolute value of whatever a is, okay? All right, now what about period? Well, period for the normal sine functions and cosine functions is 2 pi, or 360 degrees, okay? Let's look at this illustration. Okay, now this is a lot like one of the applets that I used in the previous video. And notice we have a function of f of x equals sine of bx written out here. Okay, so that's the green curve. And we're going to unwrap this circle. Okay, and notice the radius of this circle is now said to be 1 over the b value from the equation, 1 over b, okay? And that radius affects the circumference of the circle, right? Circumference is 2 pi r. Well, if the radius here is 1 over b, then the circumference becomes 2 pi times 1 over b, which is 2 pi over b. And the circumference corresponds to the length of that blue line segment there, which is also the horizontal distance traveled in one period or one cycle, okay? So what that's telling me is that I can find my period by taking the normal period of sine or cosine, which is 2 pi, and dividing that by the b value of the equation, all right? And what's at play here is a horizontal stretch or compression that's taking place. Okay, that B value is affecting the curve in a horizontal fashion. All right, now nice thing about functions of this form, the midline's not affected. Okay, the midline's still going to be the x-axis or the equation y equals 0. Okay. So, based off what we just learned there, give the period and amplitude of the equation y equals -6 times cosine of x over 5. So here I would say the a value is -6, and I would say the b value is 1/5. Okay? So my period is going to be, let's do this in terms of radians, 2 pi divided by the b value of 1/5, which is 10 pi. Okay, you have a major horizontal stretch taking place there. And then your amplitude is the absolute value of A, which is 6 units in this case. Okay. All right, now let's actually get into some graphing ourselves. Let's graph the equation y equals 4 times cosine of 2 theta, and we're going to do this for values of theta that are between 0 and 360 degrees. All right, so first thing I'll do is identify my a value of this equation to be 4, my b value to be 2. Okay, that means the amplitude is 4 units, distance from the midline to the high points and low points of the curve. And then my period this time I'm going to express in terms of degrees, and that's just based on how they want the angle measure to be between 0 and 360. Okay, so period, I'm going to take the normal period of the cosine function of 360. I'm going to divide it by my b value, which is 2, and that's going to give me 180 degrees. Okay. All right, so now I'm ready to sketch my curve here, okay? And here's how I'm going to do this. I'm going to relate it back to the 5 critical points for the cosine function, okay? So let me point those back out again. Here, 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 and here. So I have those 5 critical points, and what I want you to notice is 2 things. First is that the cosine function, it starts 1 unit above the midline, okay? And that's based on the amplitude being 1. And then the next thing I want you to notice is that those 5 points, they are all a quarter of the period apart from one another. A quarter of the period apart from one another. So if the period's 2 pi, a quarter of that would be pi over 2. So horizontally, there's pi over 2 units in between them, okay? So when I go to graph myself, what I'm going to do is take the period of this specific function, which is 180 degrees, and I'm going to divide it by 4, and that gives me 45 degrees. So I know that my points are now 45 degrees apart from each other, okay? Very first point that I know to plot is going to be the point 0, 4. Okay. Again, normally the sine or the cosine function, its first critical point is at 0, 1. But now that this function has an amplitude of 4 units, we're going to move it up to 0, 4. Okay. Then I'm going to move a quarter of the period to the right, and I'm going to go back down to my midline. So that corresponds to the point of 45 degrees, comma 0. Then I move a quarter of the period to the right again, and 4 units down. So that's the point 90, -4. Quarter of the period to the right, back up to the midline. Quarter of the period to the right, back up 4 units. So right here you're seeing 1 full cycle. And then from there, the pattern repeats itself. So now at 225, I'm at 0. 270, I'm at -4. 315, I'm back to 0. And then 360, I'm back up at 4. See how I'm seeing 2 full cycles. If the period's 180 and I'm graphing between 0 and 360 degrees, I'm getting 2 cycles. Okay? All right, let's do another one here. Graph one period of y equals -2 times sine of theta over 2. Okay? So here, the a value is -2. The b value is 1/2. All right? My amplitude will be the absolute value of -2 then, which of course is 2. And then my period, let's do this in terms of degrees again. So my period is 360 degrees divided by the b value of 1/2, which would be 720 degrees. Okay? All right. I need to make my graph from scratch here. I haven't supplied a coordinate plane on this one, okay? So before I draw it out, I'm going to make this calculation. I'm going to take the period of 720 degrees and I'm going to divide it by 4. Just like I did up in the previous problem, I took the period of 180 and I divided it by 4. So that's going to give me 180 degrees, and that just tells me how far apart horizontally my critical points should be spaced. And ultimately that'll tell me how to label my curve here, okay? So give me a x and a y axis, and on the x-axis we're going to label it in terms of 180 degrees. All the way out till 720. Y-axis we can just label by 1s. Okay? And now I'm ready to graph the function, okay? So this is the sine function built into this equation, and normally the sine function starts at the origin, right? So that's not going to change here. First point will be at the origin, and then normally for my next point, if you go back and you look at the sine function, after that first critical point at the origin, you move a quarter of the period to the right, and then you go up 1 unit to get to this point, right? Well, for this equation, when I move a quarter of the period to the right, I'm going to move down 2 units. And the reason I'm moving down 2 units is because of this a value being negative. Okay? Not only is that affecting amplitude for the curve, it's also going to give me a reflection of the sine function across the x-axis, with that being negative. Okay? Then from there, I move a quarter of the period to the right, back up to the midline, quarter of the period to the right, 2 units up, quarter of the period to the right, back down to the midline. So here is 1 full cycle. Okay. All right, one final example. Here I am given the graph of an equation, and I want to find the amplitude, the period based off the graph, and then use those to build an equation of the function. Okay. So first thing you should do is identify where the midline is. In this case, the midline is still the x-axis, okay? And the reason you want to identify that first is it can help you with your amplitude, all right? Amplitude is distance from high or low point to the midline. So in this case, I'd say the amplitude is 3 units, okay? And then what you're seeing pictured is 1 full cycle of the curve, right? So notice that horizontally, the curve is spanning from 0 out to 1080. And let's assume this to be degrees. So I would say my period is equal to 1080 degrees, right? Now I can use the period to come up with the b value that's associated with the equation, okay? So we said that the period is always equal to 360 degrees divided by the b value, right? Well, we know that period to be 1080, so we set that equal to 360 over b. We can solve here. Basically, you're going to end up taking 360, dividing that by 1080, and you'll get b to equal 1/3. Okay? Now I've done all the calculations I've needed in order to come up with my equation. Okay? Notice the cycle starts at the origin. The fact that it starts at the origin tells me I should use a sine function. If the cycle had started above or below the midline, then I would want to use a cosine function, okay? The other thing I want you to notice is that after that first point at the origin, see how the curve's heading downward, it's decreasing? That tells me my a value needs to be negative, okay? And putting it all together, I'm going to say that y equals -3 for my a value, negative because the curve starts off decreasing, and then 3 because of the amplitude being 3, times the sine of 1/3 x, or x over 3. And that's based off the b value.